Hi friends, welcome to the Unit 3 Day 7 notes. Now we're jumping into solving rational inequalities. When we solve rational inequalities, one thing that we need to remember is that we can't have zeros in the denominator. So when we talk about this on the graph, anything that makes a zero in the denominator is going to be an open dot or a parentheses. We can't divide by that number, even if this is an equality, even if this isn't equal to. So I'm going to jump in, just kind of show you like how that takes place. Here are your steps over here. We want to move everything over to the left side, and then we just want to have one rational expression. So this one's already done. We've already moved everything over to the left side. This is a singular rational expression. We want to find the zeros of the numerator by doing that using any techniques that we have. So here I'm just going to factor. This is a difference of squares. So I have x plus 3 and x minus 3. So my zeros of the numerator are -3 and 3. And then find the zeros of the denominator and note the multiplicity of each zero. So with this one, I don't know if that's factored by grouping or not. Use the techniques that you have to find the zeros. This is going to be x minus 1 squared and then x plus 1. I did this earlier. Confirm that that is in fact true. And then we want to note the multiplicity of all of these. So this is an odd multiplicity, odd, even, and then odd as well. The next part is drawing a number line as if this were the x-axis. So number line, and then we're going to plot the points. And when we plot the zeros in the denominator, those are going to be open regardless of this sign. So here I'm going to have, forgot to note my zeros in my denominator. So the zeros of the denominator are -1 and 1. So here I have a 0 at -3, -1, 1, and 3. Notice I put them all open to begin with. The -1 and 1 are going to stay open because they're in the denominator. They're part of my denominator. But my zeros of the numerator I can actually fill in here. Again, remember, because it's equal to. So then the reason I'm filling these in is because it's equal to. So either less than or equal to or greater than or equal to. And then this last part talks about plugging in one value inside one of the intervals, determine the sign of that interval, and then we use the multiplicity to determine if the sign changes. So here, if I plug in, the easiest number to check or plug in is usually 0 to see what I get, if I get a true or false statement. So if I plug in 0 in, sometimes you can't check 0. We'll talk about that here in a bit. So 0 squared minus 9, and then 0 cubed minus 0 squared minus 0 plus 1. So you notice everything cancels out except that -9 over 1. -9 over 1 is -9. That is true. So because it is true, then I know that this part here, 0, which is between these, that this is going to be below. If I think about this graphically, this is going to be below where my my x-axis. So these are going to be negative. Talking about multiplicity, at 1, it looks like it bounces. And then -1, it's going to intersect or go through. So here, it's going to be, so here from negative here to 1 it bounces, so this is going to be negative as well. This is, so above 3, it's going to intersect, that'll be positive. Here it intersects at -1, so that's going to be positive. And then here it intersects, so that's going to be, so this is going to be negative. So my solution sets, because we want to know when it's less than 0, are going to be anything with these values. So interval notation, I'm going to start from -infinity. I'm going to go to -3, inclusive, because I can include it, union. Now be careful here, -1 here is not included. and we don't include 1, so I'm going to go from -1 to 1, non-inclusive on both, union 1, and then to 3, inclusive. So that's my solution interval for this one here, for 3A. For 3B, what I need to do is I need to first move everything over. Alright, hi friends. There's probably a bad cut at this point in the video. I realized after I finished this problem, I was doing it incorrectly. So let's talk about how to actually do this correctly. What you're doing when you have these rational functions and then comparing it inequality to another rational function is you're finding out which values of x are going to be less than or equal to the values that x plug in here. So essentially what we end up with is we end up with kind of like a sandwich graph. If we were to graph these and find out where it's true between these, we're going to find out that the graphs kind of overlap in like a sandwich shape. But to get these to solvable with just using algebraic means, I'm going to subtract everything on the right-hand side. So I just have it over on the left-hand side. So I'm -1 over x plus 3. So subtracting everything over there. So that gives me, on the left-hand side, it's going to give me x minus 2 over x minus 3 minus 1 over x plus 3 is less than or equal to 0. And then what I usually do is change this to a plus, distribute the negative sign to everything in the numerator, and then go from there. All right, now I want to note these in my denominators. I've got an x minus 3 and an x plus 3, so I'm going to have to deal with when x is not equal to 3 and 3. So those are going to be kind of points that we'll need for when we do the last part to find where the solution set is. I need to essentially combine these, and to be able to combine them, I'm going to multiply. In this case, I'm going to multiply by the convenient form of 1. So for this problem, the convenient form of 1 is going to be x plus 3 over x plus 3. So that gives me x plus 3 over x plus 3 times x minus 2. Sorry, I'm going to switch back to blue so you can see the original. So now I have x minus 2 over x minus 3 plus, and then over here on this side I need to multiply by x minus 3. Excuse me, x minus 3. X minus 3 over x minus 3. And then I have -1 here and x plus 3, and that's less than or equal to 0. Okay, so now going through, I can combine my numerators because I have the same denominators. So here I'm just going to leave the denominator as the same, and so that's just going to be x plus 3 and x minus 3. So now my numerators for here, if I multiply these out, I'm going to have x squared plus 3x minus 2x is plus x minus 6. And then here on this side, I'm going to have this -1 distributing to both. So I have negative x and then plus 3. And then I have this less than or equal to 0. So now if I simplify this side, what I'm left with is x squared. My x's cancel, minus 6 minus 3. So I have minus 3 equals x plus 3 and x minus 3, less than or equal to 0. So now if I factor my numerator, I'm going to get x. So x squared minus 3, if I solve this for when these are true, what you're going to end up with is x squared equals 3, square root. Oh, sorry, plus minus is on the wrong side. Plus minus. So I get x equals plus or minus the square root of 3 for my solution. So now on my graph, I have a lot of things, 4 numbers to keep track of. So I have -3, which remember those are going to be open. That's an open one. I have negative square root of 3. That's going to be closed because it's equal to. Positive square root of 3, also closed. And then 3, which is going to be open. Now to find where 0 is, I can plug in 0 and check. So I plug in 0 and check to see what's happening here. I'm going to end up with 0 squared minus 3, so -3 in the numerator. So when I test to 0, I end up with -3 in the numerator. Sorry, that's kind of hard to see. All of my pins are dying. This is a very inopportune time for them to die. looking for something that's darker colored. Nope, that's even worse. All right, keep with pink. Test 0, so I have -3 in the numerator over, so I have 0, so 3 times -3, so that's -9. -3 divided by -9, we're checking to see if it's less than or equal to 0. That's going to be 1/3. 1/3 is not less than or equal to 0, so that's false. So in between here, this is going to be positive. And just to note, all of these change signs as each one goes through. So this is going to be negative, and then this is going to be positive, this is going to be negative, and this is going to be positive. So my interval is going to be from -3 to negative radical 3, inclusive, union, inclusive radical 3 to 3, non-inclusive. So that is my solution. Thank you for joining me. Have a wonderful day.